So this is 6.3, B as in boy. We're still solving or looking at solutions of polynomial equations, and we are in example 4, using factoring by grouping. And this has to do with x is in thousands of dollars. So the total cost of producing a product is given by this function, where x is the number of hundreds of units produced. So whatever x is, multiply that by 100, and that will be how many units produced. So how many units must be produced to give a total cost of $45,000? Okay, so because c of x is in thousands of dollars, they're giving me $45,000 to use. So I'm going to use 45 here because that is in thousands of dollars. So 45,000 is actually what that 45 represents. So we're going to solve that. Okay, so if we set it equal to 0, makes it a little bit more doable, although with all of these terms in here, it kind of makes it a little scary. But we've kind of had some experience with grouping. So if you look here, you can look at the different things and say, well, you know, I've got a couple x's there I could factor out. I could factor out a 3 there, okay, if I have it in the order. If I had it in a different order, I'd be like, well, I can factor one x out of those two. I could factor a 12 out of there. So it doesn't matter really what order, as long as when you look at these, you can group them together in pairs and be able to factor some things out. So let's look at this first group right here. Let's factor out an x squared, leaving with x minus 12. And I'm going to factor out a 3 there, and that's going to leave me with x minus 12. Now, when you're factoring this stuff, if you can group, these have to be the same. If these are not the same, then your grouping is not going to work for you. Okay? So what we do is we take this and this and put them together. And then we take the x minus 12s and just write it down once. Now, if we multiply this together using FOIL, we're going to end up getting this back, or actually getting this back, okay? So this is the correct way of grouping. All right, so once we have it grouped, now we have to find x, and that's why we group it. So we set them both equal to 0. So x squared equals negative 3. Okay, that does not work. I mean, we're looking at cost and number of items. You can never have a number that's going to fit in here for x that's a real number, which is a counting number, that is going to give you negative 3. So that one gets thrown out. So the only other option here is x equals 12. Okay, so this was in hundreds of units. So 1,200 units will give us a total cost of $45,000. Okay, so simple grouping there. All right, let's jump into the root method. This is taking the root of both sides. Notice that in the green there on the bottom of page 459, they give us x equals the nth root of c. If n is odd, we get x. If n is even, we get plus or minus the index of n to the c power. Okay, so we get plus or minus there if our index is even, and we get just the positive, or called principal root, if that n is odd. So, for example, we go to the example 5, the root method. We have x cubed equals 125. Now, if we're trying to find x, we're going to take the cubed root of both sides, and that gets rid of all of this stuff. Okay, if the root and the exponent, or if the are the same, or in other words, if the index, which I should have called it right there, is the same as the exponent, you can take all the junk off and just be left with your base here. Then we take the cubed root of 125. What number times itself 3 times gives me 125, and the answer to that is 5. Now, if we look at B, B gives us 5x to the 4th, and they're saying that equals 80. Divide by 5, we're isolating our variable, and we get x to the 4th equals 16. So then we take the 4th root of both of these, and because it's even, we take plus or minus. So plus or minus the 4th root of 16, which is going to be plus or minus 2. So there's 2 answers there, positive 2 and negative 2. All right, let's jump to C. 4x squared equals 18. Divide by 4, divide by 4, we get x squared equals 9 over 2. Take the square root of both sides, and obviously we're going to do plus or minus there. So x equals square root of 9 is 3 over square root of 2. Now the book leaves it that way. I don't like leaving it that way because the rule usually is it's not reduced unless that radical in the bottom is gone. So if you have a radical in the bottom, multiply the top and bottom by that radical, and the square root of 2 times the square root of 2 is 2, and then we have that on the top as we multiply that. This is the more correct answer, I believe, than leaving the radical on the bottom. I will not count it wrong if you leave the radical on the bottom, since the book obviously is not teaching you to do that, but that would be a good thing to do. All right, so example number 6. Get into some story problems there that you all love. Future value of $10,000 invested for 4 years at interest rate R, compounded annually, is given by, again, I'm more concerned with the formula. Okay, so you've seen that formula before. So it says find the rate, R, as a percent for which the future value is 14,641. So 14,641 is my S. And I'm looking for R. So I'm going to have to isolate that doggone R that's kind of in the middle of a bunch of goop. So I'm going to divide by 10,000. Divide by 10,000. And that's going to give me 1.4641 equals 1 plus R to the 4th power. Now if I take this to the 4th and this to the 4th, and because again it's even, it's going to be plus or minus, I get plus or minus 1.1 equals 1 plus R, because all of this stuff comes off there, and we take the 4th root of that using, I think the button looks like this on your calculator. Okay, and that just tells you that you can use any number you want for the index, any number you want for the base there, and go from there. Okay, so we have the 1.1 equals 1 plus R. Let's keep going here because we're trying to solve for R, and we find that 1.1 equals 1 plus R, or negative 1.1 equals 1 plus R. So if it's 1.1, we get 0.1 equals R, and over here we get negative 2.1 equals R. So which one is right? Well, the negative number here, the R equals the interest rate. We're not going to have a negative interest rate. Okay, so we're going to throw that one out and keep that. And 0.1, it said leave it, put it in a percent. So 0.1 is 10%. And that's it. And you can do this using your graphing calculator. You plug that original problem in and look at the example for figure 6.26, and it will give you everything you need in order to figure that out using your graphing calculator. All right, so it looks like example 7 is pretty much exactly like what we've done. They give you the function, and they want you to plug that information into your graphing calculator, obviously, because that'd be a monster to try to solve algebraically, although it could be. And go ahead and find out, what are we using? Estimate graphically the years after 1970 when the population is and will be 900 million. And if you look at the figure 6.27, it shows you what your graph should look like. Example 8, talking about international visitors. It's the exact same thing. You're going to take that equation, y equals 0.0101x cubed, yada, 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 plug that into your calculator, and it will give you the answer that you're looking for. Okay? So, let's see if there's anything weird in here. Not really seeing anything. Okay, so, your homework. Make sure that I covered everything. 6.3, 1 through 4, you're just solving the polynomial equation. Shouldn't be too bad. 5 to 10, you are solving the polynomial equations by factoring. 11 to 14, you're grouping. 15 to 18, you are using the root method, and then it keeps saying check the solutions graphically. I'm not really concerned about that, but if you remember the root method, look at number 18 real quick. Okay, you're going to divide by 2, divide by 2. Fortunately, they make it very nice. Yep, that's neat. Okay, so yeah, we move this, or the 162 was a minus, move it to the other side. Take the fourth root of each side, and it becomes a plus or minus. Those go away. So x equals plus or minus the cubed root, or the fourth root of 81, which is 3. Okay. 19 to 24, use factoring and the root method to solve the polynomial function equations. We didn't do anything like that. I don't know. I know we didn't. We did each, but we didn't do just one or the other. So, number 24, if we took x to the fourth minus 10x squared plus 25 equals 0. Sorry, I had to put you on pause for a minute. My dog ran off. So, anyway, gosh, where the heck am I? What number is this? Oh, yes, number 24. All right, so there is a method to doing this, if you remember. I don't know if I've gone over it in this class. Gosh, I teach too many math classes. But we take that middle term and we make it equal to u. That's when these are even number and they're bigger than an exponent of 2. So what we do is we take that middle term and make it equal to u. And then whenever we see an x squared, we put a u in its place. So this x to the fourth can really be written as x squared squared. So there's an x squared there, so I'm going to put a u there with a squared on it. Minus 10, there's an x squared, I'm going to u there. Okay, so then I can make it, because I just have a quadratic equation here. So u equals 5. But u also equals x squared. So therefore, x squared equals 5. So now I can take that, and wherever I see an x squared in my beginning problem, I can put a 5 in its place. So let's erase all this stuff, because we found out that u and x squared equals 5. Do this in blue here. So I'm going to put a 5 in for x squared, which gives me my squared there, because this was x squared squared. So I put a 5 in for that x squared, and leaving me with that 2. Minus 10 times x squared, 5. And I get 25 minus 50 plus 25 equals 0. I'm just checking that to make sure that that's a true statement. So, to keep going with this, I have x squared equals 5, or take the square root, plus or minus x equals plus or minus the square root of 5. Okay, so that's number 24. That's how you do it using factoring and the root method to solve. All right, so you've got 25 to 29, 30, and then you've got your story problem. So you should be good to go, and we'll continue on with Chapter 6 later.